Okay, we're going to solve this inequality algebraically, showing a sign graph for our work. We have 2x minus 1 divided by x squared minus 9 less than or equal to 0. This is nonlinear for a few reasons. The main one is because we have variables in the denominator, also because we have a variable squared. Okay, so first step is to compare to 0. That's already been done for us. The next step is to factor. Now the numerator does not factor, but the denominator is a difference of squares, which factors as x minus 3x plus 3. Okay, now that we have it factored and compared to 0, we need to find split points. This comes from setting every factor in the numerator and the denominator equal to 0. Doesn't matter what the inequality is, you always find split points by setting factors equal to 0. And this gives us three values: positive 1/2, 3, and negative 3. Split points are then put onto number line in numerical order, of course. Negative 3, 1/2, and 3. And we want to build a sign graph. It's called a sign graph because the only thing we care about is whether we're going to get positives or negatives out of each of these 1, 2, 3, 4 regions. And we test these 4 regions with any point located in the region. So pick your favorite number less than negative 3. I'm going to pick negative 5. Pick your favorite number in between negative 3 and 1/2. Mine is 0. Favorite number between 1/2 and 3. Mine is 2. Maybe yours is a different number. It doesn't matter as long as it's in between these two values. And your favorite number larger than 3, I'm going to pick 11. Okay, now we take the test points and put them into the factored form that's compared to 0. And again, all I care about is the sign. So 2 times negative 5, that's negative 10, minus 1, that's still negative. And the denominator, negative 5 minus 3, that's negative. Negative 5 plus 3 is negative. Now I have a combination of multiplication and division with 3 negative numbers. That will give me negative overall. Now let's test 0. 2 times 0 is 0. 0 minus 1 in the numerator, negative. In the denominator, 0 minus 3 is negative, but 0 plus 3 is positive. 2 negatives and a positive when I multiply and divide gives me a positive overall. Now 2. 2 times 2 is 4. 4 minus 1 is positive. 2 minus 3 is negative. 2 plus 3 is positive. 2 positives and a negative give me a negative overall with multiplication and division. And then finally 11. 2 times 11 minus 1 is positive. 11 minus 3 is positive, as is 11 plus 3, so that region is all positive. The signs do all alternate, but you can't trust that because sometimes they will not. You do need to check. How do you use that to answer the problem that's been asked? We need to know when we plug in, where do we get values that are less than or equal to 0? So in this case, that's the negative regions. Now typically, when there's an equal to, we just use brackets on the non-infinite numbers. But when we're doing one with a division, we have to make sure to never divide by 0. So what's best is right when you find the split points that came from the denominator, I recommend you put open circles on the number line to help you remember these two numbers can never be included. Split points that come from the numerator, those are fine. It's only the ones that come from the denominator that you have to avoid. So keeping that in mind with my negative regions, here's my first negative region. I go from negative infinity to negative 3, and I need a parentheses. Then I have a second region, which I can join with either a union or a comma. The 1/2 I can include, so since there's an equal to here, I do want a bracket 1/2. To 3 with a parentheses because that would make a denominator 0, and just like negative 3, I cannot include it. So here is my answer. Now one last thing. It seems like from the beginning, why not just multiply by the denominator? It's because we have an inequality. In inequalities, if you multiply or divide by a negative, you have to change the direction of the inequality. Our denominator has an x. We don't know if this will give us a positive or a negative, so we don't know whether or not to flip the inequality. You can never multiply an inequality by a variable x. It's why we have to go through this process.